Hey everybody, Kyle here with Spicer Designs. Damn it! Welcome back to the channel. Today's video, we're going to solve this problem by making an extension cord for your welder. The bigger problem is probably my piece of welding cart, but I am working on a solution. Sneak peek, there it is. This video will be coming soon. I've only been working on it for like 2 years now, procrastinating, starting it, stopping it, whatever. The reason I stopped that video is because I needed a break, and I have since gotten a break, which I made a video on. I'll link that in the description or at the end of this video. So now I'm ready to roll. Now before we get started with today's video, I'm just gonna put a couple things out there. If you already know how to do this project and you're only watching the video just to critique me, save your time, don't leave the comment. I'm only gonna delete it because they are freaking annoying. But if you're here because you wanna learn, this video is for you because I'm going to show you every step, every piece of material. It'll be a very easy to follow video for you. And just to make you feel better about that, I am an electrician. I have been for 20 years, so I know what the hell I'm doing, and I'm anal as f***. That's the only way I can put it. Now this welder right here is a Hobart Handler 210 MVP. Pretty nice MIG welder. I believe that you can purchase these at Tractor Supply, Rural King. You can pretty much get these things anywhere. And I would say that this size and style MIG welder is probably the most common welder that you're gonna see in most homeowners' garages. And the extension cord that I'm gonna show you how to make today is going to work perfectly with this setup. And we are going to be using the most common welding receptacle, which is a NEMA 6-50R. But I will have links for all of the plugs, the male end, the female end, the cable itself, links for everything down in the description. So all you have to do is go down there. It's all right there for you. Everything you need in one video. Let's get started. Okay, here we have it. I pulled everything apart just to rebuild it for you. So if there's a chance that this video does well and you are new here to the channel, please consider subscribing. Hit that like button if this video was helpful for you, but don't do it yet because it may not be, I don't know. And check out some of our videos. Got a lot of variety on the channel, and there's a very good chance you're gonna find something that you might like. So here's what we're gonna need. Starting with the tools, some kind of a utility knife, maybe a pair of pliers or channel locks or both. Something to cut the cable with. I use these diagonal cutters. You could use a pair of Kleins or side cutters or actual cable cutters, whatever you want. You can freaking gnaw through it with your teeth. I don't really care. Screwdriver, Phillips, flat blade, probably both. Wire strippers. These things are kind of pieces of crap. That's why they're not in my actual tool bag, but my tool bag is in my truck. So this is what I'll be using. Onto the material. Of course, the most important thing is the cable. Now this cable that I have here was something that I got from work. We just had it. This is an 8-gauge 4-conductor SOOW cable. We call it SO cable. And this is roughly around 25 foot long. You do not need 4 conductors for this welding extension cord. You only need 3. So the link that I'll leave in the description is going to be for an 8-gauge 3-conductor. I personally wouldn't recommend going over 25 foot on this extension cord. You start running into voltage drop issues and it could affect the welder. Anytime you start putting that load further away from the power source, you can get some issues. I won't go into all those details. I would just say, if you can get away with 25 foot max, that would be ideal. Next, 2 important things are the male cord end and the female receptacle. Now there's a couple different options for the receptacle. You can do an actual receptacle and put it in a box like we're gonna do here, or there's different styles of these. I'll put both versions down in the description. And again, this is a NEMA 6-50R receptacle. And then we have the male end, which again, links. Now since we're installing it into a box, we're gonna be using just a shallow 1900 box. This is a steel box with different knockout enclosures on it. I've already got the 3/4 one busted out in it. And we're gonna be using what is called a CGB or a cord grip. These things come in all different sizes as far as the knockout threads or as far as the diameter of the cable that you're using. So I will leave the exact one that you need in the description if you decide to go that route. And what we refer to as a Garvin cover. These also come in a lot of different variations, but I'll have all that laid out for you. And that is it. It's really not a big project. It's actually really, really easy. All right, first thing we're gonna start off, we're gonna put the male end on this thing. Now, I would recommend using some gloves. I'm not going to because I'm an idiot. So first thing we wanna do is just pull the cover off this thing and just see what the hell's going on inside here. You can see this is where the cable's going to go in, and then you can clamp it down so it doesn't pull out. Not a fan of pulling out anyway. And then you've got these 3 tabs right here. You got your ground and both of your hots. Pretty clearly marked. You've got gold screws and a green screw. It's hard to mess that up. So we can see here where we want this cable to go in. We really only need to strip like 2 inches of this outer jacket. So we'll grab our utility knife. We're going to very lightly score this outer jacket all the way around. And we'll go ahead and put a cut across this way. And as long as you have it pretty close to being cut all the way through, it should kind of tear open. Just lean more on the side of caution. You do not want to score those conductors on the inside of this jacket. All right, there we go. The jacket is off, and then you got all these little filler pieces in here. Let's use our diagonal cutters and clip them off. All these cables are kind of different, so it may not look exactly like this. Just depends on what cable you get. All right, there we go. We got our conductors. Again, this is a 4 conductor. We do not need this 4th conductor. What we're going to use is the black and the red and the green. Your white is typically used as a neutral, and your black and red are typically used as hot conductors. So we're just gonna go ahead and clip off this neutral, or this white, flush. Now we're gonna kind of line these things up, and we could trim them down to the correct length. Now, right where this clamp is right here, the silver piece, we want that to completely compress down on this outer jacket. So we're gonna kind of hold it where that outer jacket just kind of goes on the inside of that. And then we can look at where we need to cut our conductors. So we'll take our diagonal cutters and cut it right at the end of the green. That one right there on that terminal. So you can kind of see everything is trimmed to length now. So all we have to do, strip these out, and we can go ahead and clamp them down. This is where you're gonna need your wire strippers. Most wire strippers aren't gonna go up to 8 gauge, so not really doing this the way it should be. If you kind of lightly score it, you can just pull that jacket off. It'll kind of rip off there. Now when you strip the insulation off these conductors, you want to make sure that you strip them about the same length as that compression clamp right there on these terminal locations. All right, now just go ahead and loosen up your clamp. Mine's already loose, or you can completely unscrew it and take it off. That's up to you. So I kind of twist these things together like so. Kind of just holds all those strands because you don't want those strands separating. And then you want to kind of pre-form it. That way it lines up just right when you go to put it in there. All right, there we go. We got them all slid in. This part is kind of tedious, so you got to be patient. Clamp them down with a screwdriver and get those suckers good and tight. Loose connections are the worst thing for electrical. Double check them all. All right, let's go ahead and get this clamp back on there. So we're gonna wanna run these screws down on the clamp and get it nice and tight. Now before we go ahead and throw the cap on this, just do a real quick visual inspection inside here. Make sure that none of these hot strands are touching each other or the ground. Make sure everything's tight. You do not wanna have something short out in here because as soon as you plug it into the wall, it's gonna pop in your hand, and that is not good. Everything looks good. We'll throw the cap on. And this end will be done. If I can line up the freaking screws. Now you'll notice on these prongs here, it may be hard to see. These are the 2 hot prongs right here, and then this is your ground. These are both different sizes. One of them's fatter, one of them's skinny. It's not super critical because this is single phase, but good practice would be to note what color wire you landed on the larger prong or the smaller one, or both, doesn't really matter. That way you can land that same wire on the larger slot of the receptacle. So in our situation, we landed the black on the larger one and the red on the skinnier one of the 2 hots. So that's one end. If you got this put together successfully, pat yourself on the back, maybe go grab a beer, shotgun it real quick, and come back and get ready for the other end. I can pause and wait. So today is December 1st. I hope everyone had a great Thanksgiving. Obviously, people are gonna watch this video at different times, so it's kind of irrelevant. I did just post that our apparel is ready. We just released some t-shirts and hoodies with the Machine brand. Machine. Thank you to everyone that purchased them. I did just put in a pretty large order. This was kind of a trial run, and that order should be ready sometime around New Year with another batch of hoodies and t-shirts, and I'll probably be ordering more hats as well. So if you're interested, email me at spicerdesignsllc@gmail.com and we can get it all figured out. All right, now we're gonna do the other end, and for that we're gonna need the junction box, the cover, of course the receptacle, and I dropped the frickin' CGB. The CGB. So first thing we can do is go ahead and strip this wire out again. Same as the other end, lightly score it. But for this one, we're gonna want at least like 6 inches of conductor. 6 inches would be ideal. If you've only got 5, that's okay too. A little trick when you're stripping out a longer piece here, you can actually score it and then bend it over, and it'll actually either break on its own, or if it doesn't break like that, you can take your razor and just kind of lightly score it, and it'll just keep cutting it down until you can see it starting to pop through. Just another way to do it so that you don't score that wire. And rip all this crap off again. Again, we do not need that white conductor. Now you can leave it in the box if you want. I'm just cutting it off because I don't need it. Now we're gonna strip these things out next on these receptacles. It may be hard to see, but there's actually a spot here on the metal where it says strip gauge, and it actually gives you a length on how much to strip off. And it's just about a 1/2 inch. Okay, so we got our cable end all prepped and ready to go. Now what we're gonna do is I've got this 4x4. We call them 1900 boxes, or you can call them a 4x4 or whatever the hell you want. This is a combination box, so it has 1/2 inch knockouts and the option to knock out 3/4. I have a 3/4 thread CGB because this is a larger cable. So I've knocked out the 3/4 hole right here in the middle, and we're gonna go ahead and just thread this thing into it, which is pretty easy. It's got a little lock ring on it. Put it in the hole and put your lock ring back on, tighten it up. And here you may need a couple pairs of pliers. These are my crappy ones. My good ones are in my bag, which is not in here. All right, you make sure that is good and tight, and I'll show you how the CGB works. It's pretty easy. Basically, you unscrew this outer section right here. There's a little metal piece. It's like, it looks like a washer, but it's kind of concaved. So you'll just put that inside there. And then you have this little rubber grommet. This little rubber grommet is pretty much what size to fit the diameter of your cable. So you can basically leave all of that in there just like that. And then the inside of this is tapered. So as you tighten this, it'll actually squeeze that rubber tighter on that cable, and that's what basically clamps down on it. So if you just screw it on there real lightly, that rubber won't start to clamp down yet, and you could push this cable through. So we're just gonna take it, try not to mess up any of your strands, and we're gonna push it. It's kind of a tight fit on this one. Might have to spit on it. If you do have trouble, you can take this completely off and just slide it on manually, because this is a little tight. So I'm just gonna slide this rubber down it. So you want to have a little bit of distance there from that outer jacket. You don't want it to be right on the edge where it could possibly pull out of there. That's not a good situation. Now we can slide it back in. That rubber will touch, and then we can screw this back on. Your channel locks and tighten this thing up good and tight. All right, once we have everything tightened up here and in the box, this is actually a really easy part here. We're gonna take our receptacle, kind of twist our strands together here a little bit, make sure all the clamps are loose. Now on this one, it's a little different setup. One of them is gonna be marked green. Sometimes the actual screw will be green. This one just says green. That is where our ground is gonna go. So we're gonna put that one in first. Tighten it down. Sometimes these feel tight, but They're not, so you really got to crank down on them pretty good. And then check your connections, kind of wiggle on it. All right, there's kind of a little layout on the back of this. They're all going to be a little different depending on what kind you buy. But this one right here is going to be our larger slot. So that is where our black is going to go. Plug that in. Yeah. And our red. Be very mindful where the edge of the jacket of that conductor is. You do not want the actual jacket to get caught underneath where the screw clamps down on the conductor, because that could possibly affect that connection. It could get hot and cause problems. So make sure that you're not clamping down on that jacket, only the copper. So again, check those connections, make sure everything's nice and tight. We're gonna take our Garvin cover now, and you'll see it just kind of slides right over. There's a couple of screws right here. We'll pop them in. If you have a screw gun for this, it'll obviously be faster. All right, we got our Garvin cover on. I know it's dirty because it's been used. Now what we want to do is kind of make sure we tuck our wires in there. You can orientate this thing any which way you want to. Doesn't really matter. You just want to make sure that those wires fold in there and tuck in nice where they don't get sandwiched or pinched and possibly short. Then we're going to take our 2 screws, get it started. And these just screw into the corner of the 1900 box. All right, so there you have it. Male end, female end, about 25 foot long. You can now move your welder around, make it a little bit more mobile for your shop. Definitely a nice thing to have. The other option, which is a lot easier, is you can buy these things pre-made. So I will also leave links for that down in the description. But if you have the material kind of laying around and you want to tackle this yourself, not a hard project. Now there is one last thing to do before we plug this in, just to be safe. We're going to use a meter to check continuity between all of those prongs. So any kind of multimeter or wiggy or anything that you have that can check continuity is what we're going to do. We've got our male end and our female. We're going to put our meter onto continuity. Looks like a little omega sign or like a horseshoe. We're going to do the triple test, whatever the hell you want to call it. You're going to test your meter before, and then we'll test it after. So we're going to go ground to ground. All right, we're good there. We're going to go to the smaller hot prong. We'll call it line 1. And the smaller slot here on the female. Got continuity there. And the larger one to the larger one. And we're good there. But even more important than that, we need to check continuity between each prong. From end to end on the matching prong, we want continuity, but from prong to prong, we do not want continuity. That would be a dead short. So we should not hear any beeping when I go prong to prong. Nothing. From one of the hot prongs to the ground, nothing. That is good. And the other one to ground, nothing. That is also good. And we'll also check each one to the shell of the metal on the hots. That is good. And the ground should have continuity to the shell, which we also want to check because anything metal should be grounded. And we do have continuity. So we are all good. Hopefully you understood what I was trying to explain there. Basically, if we had continuity between these 2 hots, that would be a dead short. Same with one of these hots to ground. Dead short, that's where you would get a nice little spark and the breaker would trip. And then we're going to test it again. Okay. You normally have to do that with voltage. You really don't need to do it with continuity, but it's good practice. My lead is broke. That is very, very bad. So these are now garbage. So now we can test this thing out. I'm not going to move the welder around too far because my bottle only has so much hose. We're going to go ahead and plug it into here first. It's always better to limit the times you plug into a hot receptacle. Otherwise, we'd be making a hot connection here and then making another hot connection there. So now we're only making one, or you can just shut the breaker off. Yeah, buddy. It works. I'll be honest, I wasn't sure if it was gonna work. Now, if you're on like a welding kick right now, you're trying to get your shop set up, you just bought a new welder, you need a welding extension cord, and maybe you need a welding plug for your welder, 240 volt would be ideal. I did make a video on this a while back. That video performed really well, and a lot of people commented on that video that it was very helpful. So I'll leave a link for that in the description, or I'll leave it as an end screen. But if you need that information, I got it. Cannot wait to get my new welding cart set up, because this freaking sucks. Adam and Doug both beat me to it. Now, one thing that I should have covered at the beginning of the video is camera's crooked. Try that again. Now, one thing I should have covered at the beginning of the video is that the 8-gauge wire is good for up to 50 amps. The welding plug is also good for up to 50 amps. Typically, they're used for 30 to 50 amp circuits. We can dive into this as far as you want to, but it's really not necessary. I run my welder at 240 volts. I have it on a 30 amp 2-pole breaker. The max output of that thing is like 31 amps. You want to size your overcurrent protection at 125% of the full load amps, but I never run that welder at full capacity, so this is the way it's been for years, and I've never had an issue with it. So my point is, if you're running your welder on a 30 amp circuit or a 40 amp circuit or a 50 amp, this 8-gauge extension cord will be good for all of that. Like I said, I just wouldn't recommend going over 25 foot. I'm sure someone's gonna chime in the comments with their 2 cents to make everything nice and complicated, but it really doesn't need to be. So that's gonna wrap this one up. I hope that this video was helpful for you to get this project complete. The idea was to get you everything that you needed. So make sure you check out all the links in the description. They are Amazon affiliate links, so any purchase that you make, I'll get a itty bitty titty tiny little bit of commission. Doesn't affect the price for you at all, but I would greatly appreciate it. Also, check out the other links for the DIY welding outlet. Coming soon will be the ultimate welding cart. I could promise you right now, you're not gonna wanna miss that video. This cart is gonna be freaking badass. Again, consider subscribing. Thanks for watching. We'll see you in the next one. Now, we're gonna shove these suckers right into the hole. We won't need any lube for this. That's not good for it. You have a good day.